In lab, you guys use carts to simulate some collisions or explosions or interactions so we could investigate Newton's third law. And hopefully what you saw was it didn't matter how much mass was on the carts or how fast they were going. Whenever they hit each other, they exerted the same amount of force on each other, but in opposite directions, which is really what Newton's third law says. Now, I know you guys have all heard this. For every action, there's an equal and opposite reaction. But we really need to dive into what that means. Newton's third law is different than the other two, or three, the other two laws, 1 and 2, because it actually talks about two different objects. Okay? It talks about both the object that the force is exerted on as well as the agent that exerted the force. So we're going to get into this in a little more detail. In any collision, objects exert the same forces on each other. And you've got to remember that every force actually has two things involved. There's the agent, which is the thing that actually exerts the force or does the pushing, and there's the object on which the force is exerted, the thing that gets pushed. But Newton's third law actually tells us those two things are actually interchangeable. If an agent pushes on an object, the object pushes back on the agent, which means both of them are objects and both of them are agents. Okay? Now, if the objects are different sizes, then they're going to have different accelerations, and that's due to different inertia, right? Smaller objects have a higher acceleration because it has less inertia. So the forces acting are the same, but the one with less inertia is easier to accelerate. Okay? So there are two objects in action-reaction pairs. So if we think about this, if you had a car collision where a large car hits a small car, they exert the same amount of force on each other, but the large car has more mass, so its acceleration will be less. It has more inertia. It's harder for its motion to change. When you run into a wall or push on a wall, the wall will push back on you with the same amount of force. Now, you're not going to accelerate the wall because it's attached to the ground, but the wall can accelerate you. You bounce off of it. Okay? And if you've ever played a sport, you know when you use a stick to hit a ball or a puck, you exert a force on that thing, and it's going to exert a force backwards on the stick or bat that hit it. Now, Newton's third law explains a couple different things. Jet propulsion, rockets, how they work. So, when a rocket takes flight, okay, and it flies off the ground and through the atmosphere and out into space, what is causing that? What is applying the force to make it go up? Well, the rocket exerts a force down, not on the ground. It exerts a force down on these hot gases that it's expelling out the bottom of the rocket. Because it's pushing on the gases push back on the rocket. It has nothing to do with the earth. It has nothing to do with the air. It's the fact that the rocket is pushing out the exhaust, so the exhaust pushes back on the spaceship or on the rocket. Okay? A jellyfish uses a similar process, only instead of a rocket burning fuel and ejecting the exhaust, the jellyfish pushes water down through it, and so the water has a reaction force that pushes the jellyfish forward or up. And if you had an astronaut who was floating out in space and couldn't get back to his spaceship, all he needs to do is throw something in the opposite direction he wants to go. Because if he pushes on his backpack and throws it that way, then his backpack will push on him and he'll start to go that way. Okay? So action-reaction pairs act in opposite directions on different objects, but they are the same size. Okay? So let's take a look at balanced and unbalanced forces versus action-reaction pairs. Okay? When we're talking about balanced or unbalanced forces, we're only talking about the forces that are acting on one object. And we can find the net force, and they can cancel out, and that's okay. And so if we want to make a still object move, we want to change its motion, we apply an unbalanced force to it. Unbalanced forces cause a change in motion. Okay? So if I have an object sitting here, and it's resting on the table and there's friction, then if friction pulls this way with 10 newtons, then I have to pull this way with more than 10 newtons because I've got to unbalance this force in order to get it to start moving. Now once it's in motion, the forces can be balanced. Okay? Action-reaction forces do not cancel because they act on two different objects. Okay? You've got to think about this. If one object collides with another, so these two objects, one's moving this way, one's moving this way, when they hit, this object over here is going to exert a force on this object. That force is going to be this direction. But this object is going to exert a force back on this object, and it's going to be in this direction. You'll notice I do have two forces, but I also have two objects. They can't possibly cancel out because they're acting on different objects. They don't add up. They don't subtract. Okay? So, quick summary of Newton's laws. We have the law of gravitation, which just relates mass and gravity and distance. And we know the more massive an object has, the greater its gravitational attraction. The greater the distance between objects, the less the gravitational attraction. And because of the relationship between mass and force of weight, it doesn't matter. All objects in the same gravitational field without air resistance will accelerate at the same rate. Both heavy objects and light objects. The ones with more mass have more inertia, but also more force acting. The ones with less mass have less inertia, but also less force acting. Okay? The first law is the law of inertia. It says inertia keeps objects doing whatever they're doing. It's not a force. If it's at rest, it stays at rest. If it's in motion, it stays in motion. Remember, unbalanced forces cause a change in motion. Balanced forces do not cause anything because balanced forces add up to zero. So if balanced forces act on an object, it could be moving at a constant speed or it could be at rest. The second law is just an equation, net force equals mass times acceleration, which basically says the more massive an object is, the harder it is to accelerate with a given force. And then the third law is actually unique because the third law is talking about two different objects. When one object pushes on another, the second object pushes back on the first with the same amount of force.